I'm Anil Kumar, and in this video I'm going to discuss with you complete details of sketching a polynomial function. After all, what do we need to sketch accurate graph of polynomial function? There are only four things which you need. One is we need to know the zeros, we need to know multiplicity or order of zeros, that is the second thing. Then we need to know degree of polynomial, and we need to know leading coefficient. Basically, we need to know sign of leading coefficient. We're not really interested in the number. And to check whether we have the right graph or not, we may go for y-intercept. So y-intercept is more of a checkpoint for us rather than a necessity, right? So we definitely need to know all these four things, and that is kind of a check for us. Let us see what each term indicates and how to use this information to sketch a graph. So I'll begin by taking a very simple example. Let us say f of x is equals to x minus 2 times x plus 1 times x plus 3, let us say, right? Now that is a polynomial whose degree is 3, leading coefficient is positive 1. Zeros we can see are 3 different zeros, and each zero is of order 1, right? So here let's write down what we have. We have zeros. I'll write down zeros with their multiplicity in brackets. First zero is at x equals to 2, right? So that is the zero at x equals to 2. Order is 1, I'm writing in brackets. This zero is at minus 1. The order is 1, writing in brackets. And that 0 is at x equals to minus 3, and the order is 1. So that gives you order or multiplicity. That is to say, how many zeros at that point. So there's only one zero at x equals to this. So these are x values, x equals to this, which are x-intercepts also. Now, as far as the degree is concerned, degree we'll get by multiplying these three x terms. We get x cubed, so degree is 3. And leading coefficient an, when we're talking about, let us say an is the leading coefficient. Here an is 1, so, right? Since we get an as x cubed, so we know leading coefficient is positive, right? With that information, we will sketch the graph of our polynomial function. Let us say this is the x-axis. Then on this x-axis, let us plot all our zeros. Zeros are at minus 3, minus 1, and at 1. So let us say the y-axis is kind of here. Okay, that's the y-axis. So it is minus 3. Let us say this is minus 3 for us. And then we have minus 1, minus 1. Let us say this is minus 1. And plus 2, let us say this is plus 2 for us. Now since the leading coefficient is positive, that means right side up, and since the degree is odd, that means opposite ends, right? So that is the end behavior which we get from degree and the leading coefficient. Now we have to start from one end, reach to the other, crossing from quadrant 3 to 1. Let us sketch a graph connecting these points. So approximately what we will do is we'll just go crossing them like a line. Do you see that? Because these are all linear. So they'll just cross in a fashion of a line. And you know, graph of a polynomial is a very smooth graph. So we'll make a smooth curve as shown here. Do you see that? You will notice that this crosses each zero like a line. That is what we mean. Multiplicity is 1, right? So that is like a linear function. So this crosses like a linear function. Do you see that? Now, The point which I was saying was a checkpoint. Checkpoint for us is the y-intercept, so we can find the value of the function at 0. If I substitute 0 here, what do I get? I get minus 2 times 1 times 3, and that is minus 6. So we can make this point as minus 6. So that gives more accuracy to our graph. So y-intercept is basically a checkpoint for us. Minus, we can see clearly it is negative, and that is how we actually sketch a polynomial function. Now what we will do is we'll change our equation a bit and see how it affects the graph itself. So now what I will do is I'll write another function, let us say g of x, and this time I'll change degree of these zeros. So we'll still keep the same zeros, let us say x minus 2, x plus 1 times x plus 3. These are our three zeros, but this time I will change their degrees. Let me make this degree as 2 and this as 3. How will that affect our graph? This is what we are going to see. Let's rewrite our zeros now. So the zeros for this particular function will be, this 0 is at x equals to 2. This one is at x equals to minus 1. This one is at x equals to minus 3. That is to say, if I write minus 3 here, this factor will be 0. 0 times anything is 0, right? Now let us write down the order of this 0. Here the order is 1. It's like a linear function. In this case, order is 2. It's like a parabola. It is going to turn, and in this case, the order is 3. So that 3 means there are 3 zeros at this point. When we have 3 zeros, it is going to turn like a cubic equation. So the structure will be kind of like this. Here, that minus 1, at minus 1, we have quadratic. That means it is going to turn. And this is linear, going straight as we saw in this particular case. That is the kind of shape of the graph at the x-intercepts, which is defined by the order of zeros. So that is very critical. Okay, let us continue and write down the degree now. Degree for this function is what? Degree is 3 plus 2, 5 plus 1, 6. So we have a degree of 6, and an is what? Leading coefficient. Multiply these three terms. This will be x cubed, this will be x to the power of 2, this will be x to the power of 1. We are going to get x to the power of 6. Well, we say this is positive. Is it okay? So still we have a positive degree. I mean, leading coefficient is positive. Even degree function this time, not odd, right? Now let us sketch this function. Now we'll use the same kind of model, right? So we'll have, this is our x-axis, that is our y-axis, right? Still we have same zeros, I mean the points the same, which are at minus 3, let us say this is minus 3, then at minus 1, and at 2. The end behavior has changed. Since the degree has changed to even instead of odd. Do you see that? Now let us continue to investigate further. Positive leading coefficient means right side up. Even degree means both same side. Do you see that? Now both are same side. Now let's look into the type of zeros, the order of zeros. Minus 3, we have a cubic order. That means we'll go like this, right? So we have to like flatten it out a bit and then turn. Do you see that kind of a shape? That is how we are. So when we begin from quadrant 2, we need to go to quadrant 1. Then at this 0, our graph has to turn kind of like this. At minus 1, we have another 0 which is of order 2 or multiplicity of 2. It is quadratic in nature. It will never cross at this point, however, it will turn, bounce back. Third 0 is linear, so here it will going to cross like a line. Connecting these points, we get our graph. Do you see that? So what we should do here is that we could continue this like a continuous graph. Here we'll go in this fashion, turn back, and then kind of like this. Do you see that? And here we are going to turn back and then cross like a linear graph. Do you see? That is going to be our function. graph of the function g of x. So this is g of x. I hope you appreciate how changing the multiplicity of zeros changes the graph and the type of turning points at the x-intercept. As a checkpoint, let us check for the y-intercept. So if I write 0, so what do I get? So in this case, g of 0 will be, substituting 0, I get minus 2 times 1 square, right, times 3 cube. Now that gives us a negative value, minus 2. 3 cube is 27 and times 2 is 54, negative 54. So I'll write this point as negative 54. That becomes accurate graph for the given function. Do you see that? Now one more example to complete the whole sketching of polynomials. Let us now consider the function h of x. I will change it a bit more. This time what I'm going to do is start with a negative leading coefficient, right? So let's maintain the same zeros, which are x minus 2, x plus 1 and x plus 3, right? Let me write down higher degrees. How does it matter? Let us say 7 this time on one of the functions, right? 7. And let us make this as 2, right? Let's make this as 2. Let's keep this one as linear. Okay, so we have 7 this time, odd degree. Let's analyze the zeros. Zeros, we have same zeros at x equals to 2, right? This one is at x equals to minus 1. This one is at minus 3. As far as their multiplicity or order is done, sometimes we use term multiplicity, right? So how many? At 2, we have 2 zeros, so multiplicity is 2. It is going to turn this time from here. At minus 1, multiplicity is 7, odd, and here the multiplicity is 1. Now, degree of our polynomial in this case is 2 plus 7, 9, 9 plus 1, 10, right? So it is even degree, right? As far as leading coefficient is concerned, when we multiply these three terms, we get x, but that makes it negative. So leading coefficient is negative. With this kind of an information, I would like you to sketch this graph and then check with my solution. I'm sure that is going to help you a lot in understanding the concept. So in this space, let me sketch now the graph. So what we have is zeros at 2. This is at minus 3. This is minus 3. Then we have at minus 1, okay, and at plus 2, okay. Degree is even and leading coefficient is negative. When the leading coefficient is negative, that means right side is down. Do you understand? Negative leading coefficient means right side is down. So we have a graph which is pointing downwards. Even degree polynomials, same ends. So both are going down. Do you see that? Now, we'll begin by defining the graph at the x-intercepts. At minus 3, at minus 3, multiplicity is 1, so the graph is going to cross like a line. At minus 1, it is 7, so it will be like more flat, but like a cubic function, very, very flat. And at 3, it is degree order 2, so it is going to turn back and get to quadrant 4. Perfect. We can now connect these points and sketch a good graph. So we have this as our function on that side, and then we can have this connecting here. So we go like this and then turn again at 2. That becomes this graph of the function. As you know, we can now write down our y-intercept. So what is the value? Y-intercept, f of 0, substitute 0 here, minus 2 whole square times 1 to the power of 7 times 3, minus 2 whole square is plus 4. But this negative will give us negative. 4 times 3 gives us 12. So that is minus 12 for us. So that particular function is h of x. And that is how you're going to sketch. I hope with the help of these 3 videos, you understand how to sketch graph of a polynomial. So you have to incorporate zeros, their order or multiplicity, degree of the polynomial, and sign of leading coefficient. If the sign of leading coefficient is positive, then right side is up, as we saw in these two graphs. If the degree is odd, then opposite ends. If degree is even, then same ends. Right? As far as zeros are concerned, mark your zeros and then note their order or multiplicity. If the order is 1, the graph crosses like a straight line, as we saw here at point x equals to 2. If the order is 2 or even, it turns back or bounces back. It should not cross the x-axis. If the order is odd, 3 or 7, in that case, it will like turn halfway and then cross. It crosses with flattened at the surface as shown here, right? So kind of like this, and higher the odd order, flatter it is. That is what it is. So this helps you to sketch your graph. Once you have sketched the graph, find the y-intercept and check whether you are on the right side or not, right? And then label. I hope you find this video interesting and useful. We have shown you how to sketch accurate graphs of polynomials from the information about zeros, their order of multiplicity, degree of polynomial, and the sign of leading coefficient. Note, you can use y-intercept to check whether your graph is on the right side or not. I'm Anil Kumar, and I hope and wish all the best to you. Thank you and all the best.